Hello, my name is Knut Blind. I'm from Fraunhofer ISI and also from the Technical University of Berlin. Here I present you the teaching module 2 on the role of standards in ICT with a specific focus on blockchain, which we have produced in the context of the C-Blocks project. The lecture has the following sections. After an introduction into standardization in general and ICT standards in specific, we present the basics of ICT standards before we present in the second section the effects of ICT standards. The last chapter is on blockchain standards and their specific effects. You find some basic material which is expanding what we have here shown and here in the ETSI textbook, Understanding ICT Standardization, which is available online. What are the objectives of this lecture? First, we want you to know then after lecture the various functions of standards. Then in a kind of second objective, it's to understand specifically the differences between compatibility interface standards, minimum quality and safety standards, variety reduction standards, and finally information measurement standards. And after these generic kind of functions, we want you to apply these different types of standards to ICT-specific topics. Finally, we translate these insights on the function of standards in the relation of the blockchain standards which are currently exist. Standards support everyday life since a very long time, goes back to the ancient times. Also, our professional life is more or less based on standards. Society recognized the importance of standardized measures thousands of years ago related to weight, distance, or length. Furthermore, there have been common reference systems developed which have been agreed within, but also across society, like measurement approaches and like the meter system. The rapid technical progress generates continuously a new need for standards, but also a need to update the existing ones. And the dynamics is especially high in information communication technology, including blockchains. On the other hand, standardization standards boost the progress and create bases upon which new technology, but also science can evolve. First, we have to define what is a standard, and the most general definition for a standard may be a widely agreed view of doing something, where depending on the specific area of application, doing something might be replaced by designing a product, building a process, implementing a procedure, or delivering a service. Standard ways of doing things bring a lot of benefits. Our technology works without standards simply wouldn't work, or at least would be much harder to work with. And we will elaborate these kind of different functions in the following lecture. A very famous example is that we use keyboards on our computer and other devices, and therefore we have an agreement. Furthermore, we have charging systems and connectors for our smartphones, PC, and other devices, which are also good if they are standardized. And also for related software, many devices are based on software systems, and they have their own protocol which allow then the interoperation of different blockchain of different standards. We had a separate lecture on the different kind of standardization organizations, but we have to kind of replicate that because there are different standards which can be differentiating according to their development process. We have standards which are produced by so-called standards development organizations, SDOs. These organizations have the main purpose to develop standards, and they have therefore kind of established well formalized procedures to guarantee a fair standard development process. Then we have, on the other hand, de facto standards, which are de facto adopted by industry and its customers. And these standards we call de facto standards when a critical mass likes them and also uses them in practice. And also these de facto standards can become then later also formal standards if they are approved by an SDO like ISO, ETSI, and others. Now to elaborate a little bit on how standards kind of impact our everyday life, here are a few examples. Yeah? If we are using a smartphone for browsing, then different standards are needed. We have standards for user equipment, hardware characteristics, but also safety and security aspects are standardized. Then the connectivity between the user devices and the wireless network requires standards, because here then we can exploit the functionality of this network. And also internet access and the protocols to support web browsings are based on standards. And here you see a few examples of different organizations kind of providing standards for the functioning of here our smartphone. Another example is if you use personal computers, laptops and others. And here, 15 years ago, Beidel and others, they kind of counted the standards, and they identified 251 technical interoperability standards, which are implemented in a laptop computer. And they even assume that there are more standards implemented more or less in a laptop. Out of these 251 standards, 80% were developed by SDOs and 49% by individual companies. That means here the so-called platform and de facto standards. But also going back to more basic kind of technologies like switching on a light. Here we also see different types of standards which kind of cover the generation of the energy on the one hand, then also the transmission of the energy, and finally also the installation of electrical kind of infrastructure in buildings are based on different standards. Again, you see how different standards kind of combined make our life easier by making it quite easy to switch on lights. Now, we have seen here different characteristics in practice, and now we're getting a little more into theory and differentiate 4 different types of standards or effects of standards, and also their positive but also maybe negative or critical implications. Overall, we differentiate between compatibility and interface standards, minimum quality and safety standards, with variety reduction standards, and finally information measurement standards. And we start with the compatibility and interface standards because they are most relevant for ICT technologies, because they allow the exploitation of network externalities like the kind of global communication we have realized with mobile communication. Also, they avoid the lock-in in old technologies, they increase the variety of system products, and they also improve the efficiency in supply chain. On the other hand, they might be a negative competition if monopolies take them over. They may also create a lock-in in old technologies, especially if you have strong network externalities and the switching is not in the interest of the users. But let's go into the details and examples. Compatibility. Here, standards play a really very essential role. And compatibility includes two sub-characteristics according to ISO 25010. On the one hand, the coexistence. That means an ICT service and product share common environment and resources with other independent service and products without adverse side effects. That's the one dimension. The other one is the interoperability. That means the ability of those components to work together with each other. That's also a very important characteristic of compatibility. And the overall development of the ICT sector in the last decades demonstrates and supports the very high importance and also economic importance of compatibility and interface and therefore standards. And we see in general two phenomena which have an influence on customers' behavior, but also producers' strategy in markets where compatibility play an important role. We call them network effects on the one hand, and also switching cost. And if both exist, there is a high risk that we have a lock-in in existing old technologies. Starting with the network effects. There are two forms of network effects. There are the direct one, that means the value of a good or services just increases with the number of people using the service. And examples are the telephone, but also email, social media. And then there are indirect network effects. Here the value of goods and services doesn't depend directly on the number of users, but rather on the availability of complementary and competent components. Here, like video game consoles, and also the interaction between computer hardware and software. And here on the right-hand side, you see that with the number of users, the customer value goes up, and also with the number of complementary components we have available. The other important element and dimension related to compatibility and interface standards are switching costs. Because here, once consumers or producers have invested in a particular interface or standards, the switching to another one will become increasingly expensive the more people use the standards. Because first you have to buy new equipment, like a new mobile phone, a new computer, but more important are also training costs. That means if you have to switch standards, in a sense, you have to learn how to use this new product because it's based on a new standards, then there are significant training costs. But also testing costs, because if it's not clear whether the new technology is suitable, then you have to test. That means you have three components of cost which might lead to them to lock-in effects. And the problem is that here markets and companies could get locked into inferior products and services and technologies because then producer and consumer will only switch to a better one if all others do also, and if all of them can afford the switching cost. If one of the two conditions are not satisfied, a lock-in will occur. It means, furthermore, if a standard has not been developed according to the principle of formal standardization and is owned by a single organization, lock-in is even more likely to occur because the one party has the full control of the standards, meaning maybe one company controls the standards and also its further development. And if markets are characterized by lock-ins, it means there are barriers to entry and there might be also monopolies. Here are some examples of a lock-in. Means the Microsoft is an example where here the development of the technology was shaped in a way that here the dominant position of Microsoft has been secured over time. And then there was some opportunity to open the technology because the European Commission complained about that. And then there were the option to have an exclusive franchise. That means Windows grants other suppliers to write the use of the Windows API, the application programming interface, to produce system according to its specification. The strategic role of the API is to maintain network effects and also block competition. And the use of provided file formats in Microsoft application software drives in the login effect. That's one very important example. Another example is the Apple iPod. That means here digital music files with digital rights management are purchased from Apple's iTunes stores in a proprietary AAC format, only compatible with Apple Music Media Player software. Users could not purchase music in other software environments. And after the launch of the iPod in 2001 and following a licensing deal with major music labels, iPod controlled almost 75% of the US market for paid downloads. And the digital rights monitoring conditions and the incompatibility with other music players caused conflict with consumer rights. After several suits for unlawful bundling, the digital rights management has been removed from digital music files since 2009. Therefore, open standards are very important because they have very important positive effects on the market. It means whether a standard is considered as open or not depends on the openness of the standardization process. It means in an open standardization process, any entity, be it an organization or an individual, can participate in the creation of the standard. The output of an open standardization process is an open standard. As formal standardization process is expected to meet all the World Trade Organization's criteria of standardization, that means transparency, openness, impartiality, consensus, efficiency, relevance, and consistency. With an open standard, the risk of login is reduced because the standard is accessible and implementing, leading to lower barriers to entry and lower switching costs for consumers. Compatibility standards also have to reduce transaction costs. Buyers knows that the particular piece of software is compatible with a particular operating system. The burden to verify that the software will run as expected significantly reduced. This reduction of transaction costs also facilitate the division of labor. Examples from the computer industry, that means here a computer contains components from all over the world, and the international accepted compatibility standards have led to a complete globalization of these industries. And these producers, they specialize in a specific smart kind of niche and part of the value chain to achieve economies of scale and sell their products around the world to different companies. It means we see here that compatibility standards are quite important. Minimum quality and safety standards is another category which is important for the development of market. It helps that we avoid so-called adverse selection. That means the bad quality drives out the good. It's creating trust and reducing transaction costs. However, they can also misuse via regulatory capture and also can be misused to increase barriers to entry. Now in detail. The minimum quality standards identify minimum acceptable requirements for the reliability, durability, and safety of products and services, as well as to other fields such as working conditions. They can improve welfare in the economy, but also in the areas of health and the environment. They can help to reduce the risk felt by the buyers and increase trust between the traders. If set at an unnecessarily high level, however, they can also function as a barrier to entry. A minimum quality standards can relate, for example, to CO2 emissions generated through car use, but also ICT use, when adopted by regulation, such standards might become compulsory by law, make it necessary for the car producers in this example to respect the minimum quality standard. Customers face a huge choice of different products and find it really hard to assess which one is suited for their purpose. And if they cannot distinguish between different product variants, it's hard for the quality seller to sustain a high price or premium price for his high quality products, especially if the cost exceeds those of low quality sellers. And here Gresham's law applies. That means here bad quality drives out the good quality from the market. And the worst case is that the market will break down, especially for the high quality segment, and lead to a market failure. Means here are some examples of product characteristic which you have to make a decision. Quality standards or safety standards, they address the problem of information asymmetry. Information asymmetry arises in markets if one party, that means the seller, has more better information than the other side, that means here the buyer, and therefore it's making hard for the buyer to make an informed decision. Leland showed that minimum quality standards can help to overcome information asymmetry because they function as a reference and define the minimum requirement a product should fulfill. Some companies even trade on their reputation and can really sustain a price premium based on the quality which is above the minimum threshold of standards, which you see here at the right-hand side. That means the standard defines a minimum quality level, but this company has a higher quality level. It means a further aspect is the export restitution. That means a guarantee, which can also work as a substitute for a certified minimum quality standard. That means you get a guarantee and can be sure if the quality is not fulfilled, you get recompensated. Minimum quality standards can also reduce transaction source costs, which is caused by a change. That means the transaction in the market, and if a product is defined in a way that reduces buyer uncertainty, the buyer's risk is reduced, and there's less need for the buyer to spend money and time on evaluating different products before a purchase. Here, product certification can function as a shortcut for buyer because it might prove the compliance to a standard by a specific company or by a specific product. What do minimum quality standards mean for new market entrants? The general presumption is when the product characteristics are documented in a standard, the playing field between the incumbent and the entrant gets leveled. In the absence of standards, the incumbents have an information advantage over entrants. But quality standards can be set at an unnecessarily high level to deter entrants from an entry. That means here then they turn into a negative impact. Even if those standards impose a cost burden on incumbents, this strategy can be very effective. The cost burden on entrants is still significant. That means here you might raise rivals' cost and increase entry barriers. The concept of regulatory capture can be considered as a variant of the rivals' cost concept. Here, the basic idea is that some producers may lobby to persuade the regulator to define regulations on their interest rather than on the interest of the buyer or the customer, which is the original intention of standards. The third dimension of standards are so-called variety reduction of standards, which applies more or less to all standards because they reduce the available kind of varieties in most cases, which allows then on the one hand to exploit economies of scale, as we will explain later, but also building focus and critical mass. On the other hand, these variety reducing standards reduce choice. And this might be then also leading to monopolies and barriers to market access. Now in detail. The two main functions of variety reducing standards are to support economies of scale by minimizing the proliferation of minimally differentiated models. Means we go into mass production and the unit cost goes down. On the other hand, they reduce the transaction cost for customers because they do not have to choose anymore between a vast number of different products. The main advantage is that they prevent the market fragmentation, and they might also support a joint vision, especially in new markets. For suppliers, this less fragmentation also means reduced risk. Variety reducing standards can also reduce barriers to entry, because the variety proliferation is sometimes used by incumbents to limit competition from small-scale entrants who cannot provide the same degree of variety. Some incumbents try to restrict entry by companies with an idiosyncratic product specification. That means they have a very specific technologies and standards which are not open for possible interested enter. Do variety reducing standards need to be defined publicly? Not necessarily. That means the economies of scale, which is the most important function for this type of standards, can also be obtained with an idiosyncratic model range of a specific country. But a store which sells clothes in really idiosyncratic sizes will probably not perform well because the consumers will be kind of confused. Now we turn to the last type of standards, the information and measurement standards, which facilitate trade, reduce transaction costs, and provide codified knowledge on the one hand, but might be also misused in the context of regulatory capture. Information and measurement standards, they contain codified knowledge and product descriptions. Therefore, these standards can be also seen as instruments of technology transfer, as they contain the work and experience of generations of different technologies, and they can act as instruments in the dissemination of best practices between different actors in the market. Information measurement standards have a positive effect on the market by disseminating knowledge. They support the building of competencies, they support spreading essential production knowledge, thus leveling the playing field for incumbents and entrants. They reduce information asymmetries, and they might also reduce barriers to entrance. These standards lower transaction costs between companies and contractors, but for example, employees, suppliers, and customers, by providing a common language, and therefore they ease the writing of job description, contracts, etc., and they also help to achieve a feasible division of labor. An example is here the digital image compression. In the 1990s, there was a rapid diffusion of image and video processing applications and advancements of multimedia technologies. And this increased the importance of compression models. International SDOs developed several standards which are describing different compression methods like the JPEG, that means the Joint Photographic Abstract Group. They offered new solutions for saving storing place and reducing transition rate requirements to industry. And many software products are based on these compression methods by sharing of digital images, remote sensing, archiving, and image search. Now, we have presented here the different kind of impact dimensions or functions of standards in ICT in general. And now we turn to some examples in the blockchain domain. Here we present different types of blockchains and distributed ledger technology standards, and most of them have their origin in the ICT on blockchain and distributed ledger technology, the ETSI Industry Specification Group, ISG, on permission distributed ledger, but also we present some Ethereum improvement proposals, EIPs. C-Blocks developed a category of blockchain standards which can be differentiated in these following kind of categories. We look at identity management, which defines self-sovereignty of the actors, privacy, anonymity, and other dimensions. The data provenance, the governance of the blockchain. That means here stakeholder reputation, including the roles. Then also token asset creation and exchange. Here on related to cryptocurrency, virtual assets, fungible and non-fungible tokens, etc. Process optimization means the transparency of processes, multi-party processes, interoperable processes, etc. Automation, here related to smart contracts, intelligent agency and robotics, and then also cyber security. Here we are also open source plays a role, but also consensus mechanism. And finally, and also very important use cases which elaborate these niches of blockchains or other relevant domains. In a first analysis conducted in 2023, the C-Blocks consortium developed its following landscape distribution, where we found that 80% of the standards are foundations, 12 is on identity management, 6 on data provenance, less than 5 on governance, 6 on tokens, 5 on process optimization, automation, security, with 30%, over 30%, the biggest share, and 10% in use cases. And in 24, this was replicated, and we see some changes. There are less standards related to foundations, and we see also less regarding security, but the standards related to use cases have been expanded to almost 27 or over 27%. Now, looking at details on the specific standards which have been published by the ISO TC 307, we see here some examples on use cases, on identifiers, data flow models, vocabulary, privacy and personally identifiable information protection considerations, identity management, reference architecture, taxonomy, overview of an interaction between smart contracts in blockchain, security management, guidance for the governance, and the overview of trust anchors for DLT-based identity management. And then here is a further list of draft standards which have been published by this group most recently. However, we want to go into the very specific ISO technical specification 23635 from the year 2022, which provides some guidelines for governance. It's a standard which comes out of the working group 5 of the ISO TC 307, who recognize that for the organizations and broader industry, it's difficult to engage in the development of DLT systems in the absence of an effective DLT governance mechanism. In the case of permissionless public distribution ledgers, they can compromise an unrestricted number of potentially pseudonymous DLT users and nodes. In permission public blockchains, they can have hybrid governance structures. And in the absence of a central governing authority, several governing questions regarding ownership, decisions rights, and others emerge, which can be not addressed by applying traditional mechanism. And therefore, the ISO TS 23635 define guidelines for the governance, which provides principles and a framework for governance of a DLT system. The document also provides guidance on the fulfillment of governance, including risk and regulatory context that supports the effective, efficient, and acceptable use of DLT system. Another example is ISO IC-27002 from the year 2022. And here it's an information security control standard, which also can be applied to blockchain-related technology. Where new work, which is the proposed work item 23095, related to distributed ledger services. It's an extension of these previously presented ISO IC 27002 for DLT application services. It's proposed by excerpt of the TC 307 Joint Working Group on Security, Privacy and Identity, and it's at the very early stage of proposal, at the stage 00. Here are the standards which have been published by the ETSI Industry Specification Group on permission distributed ledger. Here you see a little bit a different focus of topics, because ETSI has a little bit a different focus in general. But a lot of security aspects, but also related to smart contracts, are here listed. A final example of standards in the blockchain area are the so-called Ethereum Improvement Proposals, EIPs. These are protocol standards such as those governing the internet or other decentralized interfaces, but they are, the existing ones are less conclusive, and therefore the existing standards by the ITTF is a starting point, and therefore the standards concerns about the protocol and expect the document to be replaced relatively soon by standards track document. And in relation to DLT-based improvement, developing standards by agreement is also part of the process, and the Ethereum improvement proposals and requests for comments processes. And EIP is the improvement proposal process for any changes to the Ethereum environment, protocol and token standards. And unlike at ISO, the proposal is responsible for building consensus within the community and documenting dissenting opinions. That means here we see also that this type of standards is based on a little bit of different development process. What are these EIPs? They are primary mechanisms proposing new features for collecting community technical input on an issue and for documenting design decision. Then there's an EIP repository. They are maintained as text files in a version repository, and their revision history is the historical record in the future proposal. There are different types of EIPs. There are standard, meta, and informational documents. Standards tracked EIP can be further categorized as core networking interface in the Ethereum improvement proposals. They consist of 3 parts: a design document, an implementation, and an update to the formal specification. Ethereum improvement proposals describe novel application levels, conventions that affect most or maybe all existing Ethereum implementation, including contract standards such as token standards, which we will kind of look in a moment. There are these ERC-20 tokens. This is a standard for building tokens on the Ethereum blockchain. Before ERC-20 tokens, cryptocurrency exchanges had to build custom bridges between platforms to support the exchange of any token. For this reason, 6 rules were created by an Ethereum developer named Fabian Vogelsberg and placed under the name ERC-20, which means Ethereum request for comment. The ERC-20 standard is the foundation of each fully operational ERC contract. Such a smart contract can dispense tokens as well as control their supply and monitor their movement and balances. In order for a token to be compatible with ERC-20, at least the features and behavior specified by ERC-20 need to be implemented. Further functionalities can be added by implementing functions that are not part of the standard. The main purpose of the guidelines beyond the ERC-20 is to promote interoperability. That means here, very important interoperability standard between smart contracts. As a consequence, all infrastructure components such as user interfaces, exchanges, and wallets can be connected to a contract in a predictable manner. Interoperability itself is achieved because the ERC standard establishes an application programming interface. This way, third parties can access information, execute transactions, and third-party apps can be coded for each ERC-20 in a generic way without needing to be familiar with a specific token. Here are some illustrations how this works. Another example is the ERC 1155 multi-token standards. This standard outlines a smart contract interface that can represent any number of fungible and non-fungible tokens. Existing standards as ERC-20 require the deployment of separate contracts per token type. The ERC 721 standards token ID is a single non-fungible index, and a group of these non-fungibles is deployed by a single contract with setting for the entire transaction. In contrast, the ERC 1155 multi-token standards allows for each token ID to represent a new configurable token type, which might have its own metadata supply and other attributes. Finally, a further example is the ERC 5725. This is a non-fungible token NFT standard used to vest ERC tokens over a vesting release curve. The standard allows for the implementation of a standards API for NFT-based contracts, which represent the vested and locked property of underlying ERC tokens that are emitted to a respective NFT owners. This standard is an extension of the ERC 721 token, which provides basic functionality for creating vesting NFTs, claiming underlying tokens, and reading vesting curve properties. And this was a last example, and the development of these different blockchain standards is going to continue in a quite dynamic way. Therefore, this work has to been updated. Here are some abbreviations, here are references. Thank you for your attendance.